Welcome to Data Platform Virtual Summit 2022. I'm Louis Imershein, a Principal Product Manager at Red Hat. And I'm going to talk to you today about automating deployment of Red Hat Enterprise Linux for Microsoft SQL Server. The demand for Microsoft SQL Server on Linux is increasing. And in fact, 2 years ago, Red Hat sponsored a survey of 300 members of PAS, the Professional Association for SQL Server. And what we learned was that the top 3 benefits to putting SQL Server on Linux were reduced costs, less reliance on a single vendor, and enhanced performance. Nearly 1/3 of the SQL Server DBAs we surveyed already had SQL Server deployed on Linux 2 years ago. And adoption of SQL Server on Linux was expected to more than triple over the next 2 years. And we've definitely seen that in our experience with our customers to date. Red Hat Enterprise Linux was also twice as popular for SQL Server deployment as the next named Linux distribution. And we see that as well with our customers today. So what Red Hat platforms does Microsoft SQL Server run on? And how do those platforms fit with Microsoft SQL product offerings? Well, really, there are 2 platforms that Red Hat offers. Red Hat Enterprise Linux, which is the world's leading enterprise Linux platform. And it runs in, across bare metal, virtual container, and all types of cloud environments, and can run anywhere from the cloud, up in the cloud, all the way down into the edge. And it's, of course, certified on hundreds of clouds with thousands of software vendors. But there's also Red Hat OpenShift. We're not going to spend a whole lot of time on that today, but it is the leading enterprise Kubernetes platform. And it's designed to deliver a cloud experience anywhere that you need to run containers or virtual machines. It provides a full stack automated operation capability, as well as the ability to do self-service provisioning that helps teams work together more efficiently. It's also available as a managed cloud service, or you can deploy it yourself through self-managed software. So what about Microsoft SQL Server? Where does that fit? Well, SQL Server is available as traditional Linux packages on Red Hat Enterprise Linux. Red Hat Enterprise Linux, or RHEL, supports the RPM packaging system, and Microsoft SQL Server is packaged to utilize that system. SQL Server containers also can be run on RHEL, as well as SQL Server virtual guests can be based on RHEL and run anywhere that RHEL is supported. And then finally, Microsoft Azure SQL Edge containers are also supported for Red Hat Enterprise Linux Edge deployments. With Red Hat OpenShift, we have SQL Server containers that we can run, but we also have the ability to host SQL Server virtual guests through Red Hat OpenShift virtualization. And finally, Microsoft has an offering called Azure Arc Enabled SQL Managed Instance, that's a mouthful, that they're able to support with containers through the Azure Arc Enabled Data Services platform. I think I got all of that right. But the idea is that you can then run pay-as-you-go managed instance SQL Server containers on premises with management facilities available to you up in Azure. So why would you run SQL Server on Linux? Let's focus specifically on Red Hat Enterprise Linux now for SQL Server. Because there are RHEL for SQL Server features included with a RHEL subscription. It's not just about the compatibility that Microsoft supplies, or the ability to support always-on availability groups with the Red Hat High Availability add-on, or our support for our cloud services through Red Hat Insights, which is included with the Red Hat Enterprise Linux subscription. It's not even about capabilities like online kernel patching, which is something that's unique to Linux and not really available in a Windows environment. But it's also about performance, and most importantly, it's about management at scale. So what we're going to show you today is how to simplify the installation and configuration of a complex multi-server environment. Red Hat Insights, which is our cloud service included with Red Hat Enterprise Linux, provides you with best practices and guidelines, as well as the ability to remediate those issues through Red Hat Smart Management, which we'll learn about later. We're also going to talk about how you can eliminate the need to recreate Windows user IDs and passwords by using the Active Directory integration, either included with Red Hat Enterprise Linux or through third-party solutions. So let's take a look at each of these in a little more detail. First off, simplifying the installation and configuration. Red Hat Enterprise Linux includes a collection of Ansible roles that ensure consistent workflows and streamline execution of manual tasks at scale. The idea is you shouldn't have to write a script for that if someone's already written it before, and especially if you can use a script that's already supported by Red Hat itself or by someone like Microsoft, or maybe a hardware vendor like Cisco, or a cloud vendor like Microsoft or AWS. All of those capabilities should be yours to utilize again and again, and that's the idea of Ansible, which we'll talk a little about later on. But for now, we're talking specifically about the automation capabilities delivered with RHEL. And RHEL includes a technology called Ansible Core, which is the basic technology that allows you to use Ansible automation, Ansible playbooks, Ansible roles within a RHEL environment and manage that RHEL environment. So the idea here is that we're going to be able to minimize our manual tasks and execute them consistently again across physical, virtual, private cloud, public cloud, or edge footprints. And you're not going to have to know under the covers, how that's done, because you're telling the role to go manage a solution, and that solution may live in any one of those environments. Also, we have the capability of leveraging Red Hat Smart Management to take advantage of those and take advantage of Ansible automation platform subscriptions. We're going to talk in a lot more detail about Red Hat Smart Management and Ansible automation later on. So what Red Hat Enterprise Linux system roles are available today? Well, the roles that are around today for RHEL really center around security, configuration, and workloads. And for workloads, you can see we have support today for SAP and for Microsoft SQL Server. That SQL Server role was jointly developed with Microsoft and is available both shipped with Red Hat Enterprise Linux as part of our system roles that we ship with the product, as well as in the curated Ansible Automation Hub as an offering from Microsoft. So using that role today, you can install and configure SQL Server. You can tune SQL Server. In fact, a lot of that tuning is done for you out of the box, but we provide the extra bells and whistles to let you tune the storage layer. You can add and enable extras like full text search, SQL agent, PowerShell for Linux, turn on the high availability capabilities of SQL Server, and you can secure connections. You can also use this capability on day 2 to not just install certificates and keys, but also update them as well. So what's really interesting here also is that we are introducing the ability to manage always-on availability groups with the RHEL High Availability add-on. So I talked before about following best practices and guidelines using the Red Hat Insight service. And as I mentioned before, this is a cloud service that is included with the RHEL subscription. It allows you to quickly identify and resolve issues to help you avoid downtime. So it combines the knowledge of Red Hat and Microsoft in the case of SQL Server. And we'll actually use the SQL Assessment API to help identify issues and provide advice around how to configure SQL Server on Red Hat Enterprise Linux and avoid problems like not having performed backups or perhaps needing to rebuild an index to get better performance out of your SQL Server. We also provide continuous vulnerability alerts based on a huge database of Red Hat vulnerabilities. And we also provide visibility into security risks, as well as the ability to solve problems using that smart management capability I mentioned before that's available with our smart management add-on. We'll talk about that in a moment. In one study, Principled Technologies was able to use Red Hat Insights to resolve an issue with SQL Server that came out of our advisor. And they did this across 100 VMs. It took them less than 1 minute and 19 seconds to perform 19 steps that previously took them over 33 minutes to complete manually. There's a whole suite of insight services. I mentioned Advisor before. Advisor is a service that actually, underneath Advisor, you will find workloads like SQL Server and SAP, and information about those workloads and how to resolve things in those specific environments. And there also are other capabilities in there around availability, performance, and stability across your environment. There's a vulnerability service that helps you look at CVEs and advisories. There's also a compliance system that helps you make sure you're complying with various standards like PCI DSS. There's a subscription tracker. There's the ability to monitor drift. This is one of my favorites. So you can create a baseline image of Red Hat Enterprise Linux, and you can watch, as the images that you think are identical to that image slowly drift off from what your baseline was, because people are doing one-offs in those environments, which you'd like to know about. There's policy administration, patch administration to make sure that we're up to date. And all of that is integrated into the Red Hat Insights cloud service for RHEL. I should mention there are also Red Hat Insight services available for OpenShift, and there are Red Hat Insight services available for the Ansible automation platform that we'll be discussing later. So with that mindset, let's focus on RHEL. And one of the ways that you can utilize Insights the best is with Red Hat Smart Management, which is an add-on to Red Hat Enterprise Linux. Using Smart Management, you can link your account to a cloud provider account. You can connect your systems to Red Hat Insights, and you can run playback books automatically in Insights to resolve issues with your Red Hat Enterprise Linux systems. These are pre-populated playbooks that have been developed by Red Hat that allow you to go and resolve issues that we've identified and solve the problems for across hundreds of thousands of accounts. So you're relying on Red Hat support, and to some extent for SQL Server, you're relying on the knowledge of Microsoft support, and you're leveraging those scripts to use in your environment. You can review those scripts, you can play them, and you can do all of that using Smart Management. Smart Management gives you the way to provision systems by integrating in with Red Hat Satellite Systems, which is Red Hat's software management system for the Red Hat Enterprise Linux environment. You can maintain those systems by patching them, applying security updates, maintaining compliance, tracking and fixing issues with drift. And you also can deal with system retirement by upgrading systems, migrating, or even decommissioning systems. And Satellite makes that easier. In fact, it can improve the operational efficiency, your operational efficiency for these kinds of tasks by up to 28%, according to IDC. And the Smart Management infrastructure works across hybrid environments. It's designed for them. So you can manage your subscriptions in the cloud. You can manage your subscriptions on premises, whether they're connected or disconnected. So I talked before about eliminating the need to recreate Windows IDs. Active Directory integration allows you to avoid having to recreate identities when moving SQL Server users into a Linux environment. You can use the native Red Hat Enterprise Linux integration with Active Directory and use it as a single source of truth. Use AD as a single source of truth for all your user identities. But you also can apply tailored access control policies directly to Red Hat Enterprise Linux domains. And you can improve administrative efficiency by centralizing where your policies get created. So let's take a look at some of these Active Directory integration options that you have. The first is direct integration with Active Directory, where AD is the single source of truth and the single point of management for identities in Windows and Linux environments for SQL Server or even just general applications. The second is sort of a hybrid model where you use Red Hat Enterprise Linux Identity Management, or IDM. And here, IDM federates the AD environment and acts as a source of truth and point of management for the Linux environment, while AD continues to manage the Windows environment. In this case, Linux administrators can create identities that can then be managed in AD as well as used within controlled domains for SQL Server. The third case is third-party integration. And here we have support for Beyond Trust, Centrify, One Identity. I know some of you already use these solutions, and Microsoft does support them for SQL on Red Hat Enterprise Linux. And all of them are certified ISV partners, software partners, for Red Hat Enterprise Linux. So they're great solutions, and you can certainly consider using them if you'd like. I promised before to talk more about the Ansible automation platform, so here we go. One of the problems that IT organizations face is that different teams use different tools, right? So on the edge, you might use one set of scripts. In the cloud, you might use a different system for managing deployment and management of applications. In the data center, you might have a bunch of scripts written in an entirely different language. So how do we get this consistent governance across our dev and DevOps teams, our IT operations and DBA teams, our security operations teams, and our network operations teams? That's really the problem that Ansible is designed to solve, so that we can actually solve a problem across the line of business. Now, Ansible automation does this by providing a scalable, secure implementation for describing, building, and managing enterprise IT applications across your enterprise architectures. With Ansible automation, you're getting a set of cloud services that help your teams collaborate and work together to automate those diverse hybrid environments that they have. And they do this also using certified content that comes not just from Red Hat, but also from our partners, as you'll see later. The Red Hat Ansible automation platform is holistic. It's extensible, intelligent, consistent, efficient, and future-proof. So what do we mean by that? Well, Ansible assumes the work of many different solutions and integrates those in with RHEL, not just RHEL, but over 100 partner technologies. So we talked about, that we're not just focused on the operating system with Ansible automation platform. We're also focused on other operating systems like Windows and other application platforms, like, of course, SQL Server, but also different hardware platforms and cloud environments, as we'll see shortly. It's also extensible, and you can augment the value of Red Hat Ansible automation platform beyond just the Red Hat Enterprise Linux using the automation platform. So you can use it across the Red Hat portfolio for things like Red Hat Satellite, which I mentioned before. It's intelligent, so it includes automation analytics to tell you how you're doing. And Insights provides its own set of services around Ansible, including services that help you measure the ROI and prioritize your efforts around IT management. It's consistent. You can leverage automated, repeatable management workflows wherever you need to apply those workflows. And it's efficient because you're not going to be spending time on error-prone, time-consuming, one-time tasks, right? You have simple to navigate features that let you automate things faster through the automation system. And finally, it's future-proof because, the tools that we're providing don't just work for day 0 and day 1 deployment. We spend a lot of time talking about deployment, but we also help you to build and expand your networking and security beyond day 1 into day 2 and beyond, as I talked about in my example of the SQL Server rule and how you can use it to manage certificates over time. Works with Windows, not just with Red Hat Enterprise Linux, and that's really key to environments that are, have Windows as well as Linux. So there's a great flexibility there with that. And not just with applications, not just with operating systems, but with networking, with cloud, with security and infrastructure. Whether you're running VMware, which we're going to have an example with around infrastructure later, you're running Red Hat Enterprise Linux, you're running in AWS, or Google Cloud Platform, or Azure. You're running Cisco switches and need to configure them. You're using CyberArk or security solutions from IBM. You're using Splunk. There are tools available through the Red Hat Ansible Automation Hub, which is included with your subscription, that are supported by all of these vendors. So you're not having to reinvent the wheel for these different environments. So speaking of VMware, Let's take a look at deploying Red Hat Enterprise Linux for Microsoft SQL Server in a VMware vSphere environment using Ansible automation. For this, I'm going to ask my colleague Johan Odell from Red Hat Sweden to give you a run-through. And after his demo, I'll come back and we'll talk about some customer experiences.
Hi there, my name is Johan Odell and I'm a solution architect at Red Hat. In this demo, I will show how you easily can automate the provisioning of RHEL and SQL Server on VMware, but also some good tools you get access to with your RHEL subscription to monitor and optimize your SQL databases. So here you can see the automation workflow we are going to step through in the demo. And as you can see, I'm using Ansible Automation Platform. So let's start by logging into the Ansible Automation Controller. When we come in, we will land in the Automation Dashboard view, but I will head over to the Template section and pick the template I have prepared for this demonstration. So in here, we have a survey where I have exposed different configuration choices for the virtual machine. Things like host name, amount of CPU, memory, disk size, but also which template we are going to clone in vSphere to provision this virtual machine. So when we are done with the configuration and press launch, we will see this visualization of the entire workflow where the first step is to clone the template we chose from the previous step inside of vCenter. So that is what's going on at the moment. It is cloning in VMware. So if we head over to the vCenter console, we should see that our virtual machine has been cloned. Yes, there it is, and it's also started. So now it will go through some customizations and then restart. When that's done, we just need to sync our inventory to be able to access the VM from Ansible for further configurations. After that is done, we add a RHEL subscription to the VM and also some necessary repositories. Then the next step is to fix some prerequisites before we install SQL Server. That's mainly to open firewall ports for SQL and monitoring. When that is done, we can start to install SQL Server itself. And to do that, I'm using an Ansible collection from Red Hat Ansible Automation Hub. And the collection I'm using is Microsoft SQL Server collection, which is jointly developed and maintained by Red Hat and Microsoft. And it's fully supported by Red Hat through the RHEL subscriptions. So this will obviously deploy and configure SQL Server, but it's not only doing that, it's also tuning, performance tuning your RHEL operating system for SQL workloads. And this is done by adding a specially crafted tuned profile for MS SQL. So if we have a look inside the virtual machine, I will list the available tune profiles, and as part of this Ansible play, MS SQL Server is added to the system as a profile, as you can see. And it's also added to the current active profile as well. So next we are adding metrics, and for that I'm also using an Ansible collection from the Automation Hub. I'm using the RHEL system roles developed by the RHEL business unit to automate and abstract configuration tasks across many versions of RHEL. And in this scenario, I use it to add metrics. It will install Performance Copilot and start gathering data from the OS and from SQL Server and forward it to a central monitoring server. RHEL system roles are available and supported for all RHEL customers. As the last step, I'm also adding this server to Red Hat Insights service, and we will take a closer look at that later on. So this entire workflow was shortened down in time by video editing. But as you can see in the top line, this took 9 minutes and 20 seconds in reality. So during the last part of this workflow, we added monitoring locally to Grafana and then to the cloud service Red Hat Insights. Let's have a look in Grafana to see what type of metrics we can see in there. The dashboard brings together information from the Linux kernel, SQL OS, and the SQL Server database layer, and then it displays it here in Grafana panels using PCP vector graphs. Using this dashboard, RHEL admins and SQL Server DBAs can spot key metrics that might be slowing down the performance of their databases. So a great tool pre-built for troubleshooting and keeping track of your database servers. So next we are going to have a look at Red Hat Insights. And for those who doesn't know, Red Hat Insights is included with every RHEL subscription, and it's a managed service using predictable analytics and deep domain expertise to reduce complex operation tasks, focusing on areas of availability, stability, performance, and security. So it is also, we have some advisor topics where one of them is SQL Server, and as you can see here, Insights has found a performance related problem which is affecting 2 different systems. As we can see here. So you will get all information on how you can resolve and remediate these problems. But not only that, for many of the problems, Insights can actually build an Ansible playbook for remediation. So here we can choose to create a new playbook or add tasks to an existing playbook for remediation of the problem. So here we get the review of the systems that is included in the playbook, and we get an overview of the remediation as well. So if I click submit here, the Ansible playbook will be created, and you have a chance to download the playbook from here to run it locally, or if you have smart management subscriptions, you can actually execute the playbook directly from the Insights console. So I hope this was interesting. Thank you for watching. Bye bye.
Thanks, Johan. So Johan gave you a good idea of how you can configure a SQL Server on RHEL in a VMware environment, along with metrics configuration and configuration in Red Hat Insights, as well as configuring all of this so you can monitor it through Grafana, which is great. But we all know that in production environments, it's very common to want to deploy always-on availability groups. As I mentioned earlier, we do have in preview the capability to manage always-on availability groups within the Microsoft SQL Server role. We'll be shipping with Red Hat Enterprise Linux. This is currently available in Ansible Galaxy, which is the community hub for Ansible software. So let's take a look at the role. I've actually got it installed here, and I've set up a primary SQL Server with a database that I call ExampleDB. I've also set up a couple of SQL servers that I plan to replicate that database to, and that will join my availability group. Here you can see there is a directory called SQL Cluster Playbooks. We'll go in there and take a look at the inventory file, which will list my hosts. And you'll see I have 3, MS SQL 1, which is going to initially act as the primary host. That's where my database is now. MS SQL, my second one is a synchronous replica. And then my third one also is a synchronous replica. Now, we don't currently support asynchronous replicas, but we do plan to in the future. But we do support, and this is very important, configuration-only replicas, which allow you to use a SQL Server as a tiebreaker. You can literally use SQL Server Express, so a no-cost edition of SQL Server, as a tiebreaker in a SQL cluster. And so that's also an option here. But for now, we're using 2 synchronous nodes, and then the primary itself, which will also be a synchronous replica as well, if on the event of failover. So now if we go in here to step 3, step 1 was setting up my SQL Server, initial SQL Server with the database. Step 2 set up the 2 other SQL servers, and step 3 is now turning all of this into a cluster. So, and you can see here we have a lot of settings. Most of these you don't have to change a whole lot, but obviously anything that has password in it, you're going to want to change. If you look here, we of course are accepting all of the license agreements. We have to have a password for our SA user, which we may or may not decide to use later on, because depending on our security practices. We have to choose which MS SQL edition we're using, in this case developer. We want to make sure we open firewall ports for SQL Server in the Red Hat firewall. We want to tell MS SQL again to configure HA and to open the firewall for HA. We also need to provide which port HA is running on. In this case, 5022 is the port that the replication is occurring on. And we also have to set up certificates. Normally this would be done in Active Directory in a Windows environment, but in a Linux environment, we actually set these up on the hosts, and we use these passwords to encrypt the keys. It's used to encrypt the keys for when they are at rest. So, because they do get stored on the system as well as in the database. We can reset that certification. You would set this to true if we were resetting the certificates or resetting the keys. So that's a functionality I talked about earlier, sort of a day 2 management capability. We need to have an endpoint for our SQL Server, and really this can just be example endpoint, or it can be whatever you choose to name your endpoint. We want to specify what our availability group's name is. And this will be shared, as you'll see later, inside of SQL Server, as well as for Pacemaker, which is the core engine behind the Red Hat High Availability add-on. Our database is named ExampleDB. That's the database we're going to replicate. Pacemaker login you can just use. It's just the login that Pacemaker is going to use to log into the SQL Server. And that login and password is set here. Obviously, again, reset any passwords. You do want to set run role to true, so that will force that the HA cluster role is integrated in with Microsoft SQL Server. And it will, by the way, reset clustering on the server cleanly. You can see we're choosing a cluster name that's the same as our AG name. And we are setting up a password for the cluster as well. So that's a lot already. Many of these other things we're not going to change a lot at all, because in this case I have literally cut and paste a solution for fencing, which is the way that you lock down a node on Linux. I've taken that solution from the examples that are provided in the repository and in the documentation. And in this case, I'm using the one that works with virtual machines on Red Hat Enterprise Linux. This is also, by the way, the same one you would use for a bare metal configuration. So I am setting up Stoneth, which is our way of dealing with fencing. And we will run through here. You can see I'm setting a failure timeout value of 60 seconds. I am setting the agent, the OCF Microsoft SQL agent to be used, which is the agent that comes from Microsoft. I'm setting up a virtual IP address, which will be the floating IP address that we use to connect to SQL Server through the HA address, if you will. So, and this address is going to be set to .24 on my subnet. I've actually already named that mssql.ag1. So in this case, if I connect to mssql.ag1, it will always be the primary node in my SQL cluster, and I'll be able to write to it. I am going to periodically monitor my cluster and check on that every 30 seconds. I will set up what are called AG cluster resource clones, which means that one system is going to act differently from the other systems. And that system is going to be the one that will be the writable copy of the HA cluster. We'll go through here. There's some what we call co-location constraints. And again, this all pretty much is canned stuff. You don't need to change any of this. It says, we always want to make sure that the main AG cluster node is promoted, and that following that the virtual IP, that floating address, moves over as well. And then we set some ordering for those constraints. So we make sure that we're bringing up the clone first and then moving the address. So we've enabled SBD, which will be how we use a watchdog timeout, which we set for 20 seconds, to protect the systems in the event of failure. And that watchdog will time out in 20 seconds if it's not contacted by the other nodes. 20 seconds is a long time, so you would expect that automatic timeout would be a system of last resort in your clustering. There are a number of different layers in SQL Server to protect data, and a number of different ways that replication fences things for you, both at the SQL level as well as cluster fencing, which is what we're doing at the pacemaker level. And you can see here the name of the role. So let's go ahead and run this. And I'll probably have to step through this a little fast. I have run this on this machine before, and these are SSH passwords, so I can become root and access these remote systems. We're going through here. We're making sure the system is set up properly, that we've got the right version of SQL Server and it's updated. We're making sure we're skipping a bunch of steps because we've done a bunch of this already. We're making sure our Microsoft SQL Server packages are up to date. And we are making sure that supporting packages are also configured. We know that we've already set up SQL Server. Well, how do we know that? Because Ansible checks. And this is actually a key difference from your typical scripts you might know from Linux, from a bash shell or from PowerShell, in that there are rules behind how Ansible roles are designed and developed. And it's very, very important in the Ansible case, and very standard, very much a standard, that we always check to make sure that things are configured before we apply the changes. You'll notice we didn't have to open some firewall reports. It checked on that and made sure that some settings were set properly. Those settings were already set, so it didn't have to do them again. So we're going through doing all of this, and as we move through here, we're making sure that all of the components are available, and opening firewall ports, configuring host variables, making sure that we have the Microsoft SQL Server HA package installed for AG support, because that includes the resource agent for Pacemaker that it's going to use. Again, Microsoft and Red Hat collaborate really closely, so some components for this come from Microsoft, some come from Red Hat, and if you have a problem, you can call either company and we'll figure out how to resolve it together. Or you can call a partner who also has been trained to be able to support SQL Server availability groups, and they might be a one-stop shop. Say if you went to a hardware vendor, for example, who sells you your SQL Server and your Red Hat Enterprise Linux with your hardware, they might be your first stop. Or a cloud vendor, such as Microsoft, when you're running your software in their cloud. We're setting passwords, we're granting permissions for HA. One of the things that we will do here that's very interesting is, we're going to replicate this small database over to our replica systems. But we're not even going to continue on until that replication is complete. We'll actually check periodically to make sure that that's complete before we continue on. So all of these replication steps are underway. And at this point, we're doing the key encryption that I discussed earlier. We're making sure that all of our SQL commands for key encryption are set. This is for the keys that we're using for replication. We are, let's see, continue to configure HA here. We're creating an HA login, moving through the full process. And every time that we do any of these steps, we're making sure that that step has happened. And this is why it's perfectly okay to run this Ansible role again. You'll see something skipped. They're skipped because they're already set to the way that we need them to be set. So that makes things a lot easier for us, right? We don't have to redo things, and we don't have to worry about rerunning a SQL role or a script related SQL if it's an Ansible role over and over. That's perfectly fine. In fact, we need to give it instructions if we want it to do something different if it finds that things are already configured. And that's something that you saw with the cert settings when we looked at them in the configuration file. Here we are configuring the cluster firewall. We're enabling high availability. We are setting up our fencing ports. And we're not using virtualization fencing. In this case, we're using the SPD fencing, so there's nothing to set up there. So we're going through and configuring Pacemaker now, which is, again, the key component. That and CoroSync are the key components of the Red Hat High Availability add-on. We'll move through here. Pacemaker is almost up. And once that is complete, we will, we're configuring the fencing now. Making sure that everything is authorized to start at cluster. And we are making sure that that cluster is started and that membership is formed. All of those cluster settings that we talked about before, now that we have a cluster, have to be set up. So we're moving through and doing that. All those constraints that we set on the ordering of when things happen in the cluster is being configured. And our cluster is up, and we can see that nothing's failed in the process. First off, let's see who currently is the active SQL Server. And we can see here, if we look, that MS SQL 1 has the virtual IP address started on it. So that then means that it is the writable SQL Server, the primary, as we would expect, unless something went wrong, with a health check or something when we were starting up. So let's go ahead and check our SQL servers, and we're going to actually make sure that our cluster is properly configured. The first thing that we're going to do is we are going to connect to the MS SQL service address. We'll do that using SQL command. But before I do that, let's take a look at the database that was created earlier in this process. We can see there's a table called inventory, and I know that the database that we created that table in was called example DB. So I'm going to go ahead and connect in there, and we'll go ahead and insert a value into that table. Here we go. Sorry. There we go. Okay, we use example DB. Okay, and we're going to insert into inventory values. We're going to put in, say, tangerine. Okay, we'll put in tangerine as a value, and we'll list this as 190. I'm going to hit go here, and I've added the row tangerine. Okay, now if I go ahead and select star, which I know you're never supposed to do, guys, remember, but we're going to do that just to list the simple table. So don't try this at home, kids. And you can see I had also added avocado earlier, but you see the table has been updated. Now if I go to SQL 2, which again, remember, is one of the replica servers. Oops. And I use example DB. Okay, so we're in example DB. I can go and I can select and see what was set up from the previous server. But if I here were try to do an insert, inventory values, I don't really know what a foo bar is, but it seems to be very popular. And we'll go ahead and put this in, and go, and it's not going to let us write to this database because this database is read-only. You might not even want to have a read-only database, and you certainly can go in through MS SQL and ensure this database can't even be read, right? So that's an option. But by default, the system role has gone and set this as a read-only replica. There we go. That completes my demonstration today. I also recommend you take a look at my blog, which just kind of gives you an overall architecture of both SQL Server availability groups and Red Hat High Availability add-on. And then to explore further, you can look at the blog by Amit Khandelwal from Microsoft. And he provides an actual detailed example of how to configure all of this using the fencing in an Azure environment. So let's take a look at a customer and how they've addressed their challenges using SQL Server on Red Hat Enterprise Linux. In this case, that customer is XM, which is an energy company down in Central America. So if we look at the solution that they developed, they adopted a whole new reference architecture that includes SQL Server running on RHEL and supported that architecture using Red Hat applications and integration solutions. With Red Hat, XM was looking for a proven, cost-effective operating system with transparent roadmap and experienced support. After they chose the Red Hat environment, they saw the results and were extremely happy. So they were moving from an old version of SQL Server on Windows, and they were able to achieve 3 times faster transaction response running SQL Server on RHEL using that modern version of SQL Server and that modern version of RHEL. They reduced resource use by 30% per server, and they reduced administrator support and maintenance time by 60%. In the end, they deploy Red Hat Enterprise Linux, Red Hat Fuse, Red Hat JBoss Enterprise Application Platform. So they're not just deploying Red Hat Enterprise Linux, but they're also taking advantage of the middleware ecosystem that's available from Red Hat as well. So what are some next steps for you if you'd like to see some of the benefits that XM has reaped? First of all, you can learn more about Red Hat Enterprise Linux if you're new to Linux with a free online course from Red Hat's training and certification team. Start that journey with the Red Hat Enterprise Linux Technical Overview, or RH024. And that's available on Red Hat's website. I'm sure you can just search it up with Google and get started right away. Second, you can try out Microsoft SQL Server on premises in Red Hat Enterprise Linux using the Microsoft Quick Start to deploy SQL Server on Red Hat Enterprise Linux using an Ansible playbook like the one we described today. You can also try out Microsoft SQL Server in your favorite public cloud with ready-to-run SQL Server on RHEL instances that are available in AWS as well as in Microsoft Azure. I want to thank you again for your time. Enjoy the conference and have a great day.